For example 6, here you're going to be solving a trigonometric equation, but you have to find all solutions of 1 plus cosine squared x equals 2 cosine squared x over 2 on the intervals 0 to 2 pi. So since it gives us an interval, that means that we don't actually have to add a 2n pi at the end. This could be the problem that you have to do the most work on, but it's just another problem where you have to just plug in a formula. So if we start off with our 1 plus cosine squared x, and if we take out the 2 cosine squared x over 2, what we can do is we can actually leave the 2 in front, but we're going to substitute a formula here. And we're going to plug in a half angle formula, and since we have it squared, then we're also going to square on the outside. So we have our 2 here, and then on the inside of our parentheses, we're going to end up having a plus or minus square root of 1 plus cosine of x all over 2, and that's underneath your radical also, and in parentheses, and then this is all squared on the outside. So if you notice, since we're going to be squaring a square root, anytime you square something, that actually gets rid of this plus or minus and just makes it a positive. So we're going to square this, we're also going to get rid of the square root. So since we're squaring this, we're going to get a 1 plus cosine squared x equals 2 times, and we just have what's left underneath, 1 plus cosine of x all over 2. And remember, the square is gone, and so is the square root. So the square root cancels with the square. So go ahead and simplify a little bit further. We have a 1 plus cosine squared x, and on the right, the 2's are going to cancel now, so that cancels. So we end up with just equals to a 1 plus cosine of x. So now in order to solve this, we need to combine terms on the same side of the equal sign. So let's go ahead and subtract one of both sides. Then we're also, if you notice, both will cancel on both sides. We're also going to subtract a cosine of x on both sides. So we end up getting something that we're pretty familiar with factoring in 5(3), cosine squared x minus cosine of x, and that's equal to 1. So if we're going to solve this equation, it's supposed to be a minus here. So this would be a minus, not a plus, that's a minus. So here we can take out a cosine of x, and we get a cosine x minus 1 on the bottom. Oh, sorry, this equals 0. So if that equals 0, then by the square root property, you can set each of these equal to 0. And we're going to set the right side equal to 0. So then we know on the left, where the cosine of x equals 0, well, there's 2 spots. Cosine of x equals 0 at pi over 2 and 3 pi over 2. And then on the right, when we finish solving this one, we end up getting a cosine of x equals 1, and this only occurs in one place, and that's going to be at x equals 0. So your final solution ends up being x equals 0, pi over 2, and 3 pi over 2. And that is how you can use a half angle formula to substitute in to solve with using factoring techniques and problems you've done before.